tutorial, we're going to look at how we can easily drag and drop inside your list. So you can see, for example, here we have a list and we can try to drag and drop items from different places. So this one is going to be easier implemented. So we're going to implement everything from scratch. So without any further ado, let's get started. Okay, so now let's start to create here our drag and drop list. And we can easily do this by using a state. So we can use a state to keep track of everything. And the great candidate for this, let's just open up here. Okay, so inside here, let's create a new coding class or file. And let's call this. Okay, so the drag drop list state, which is going to keep track of our state. So several things which we're going to need here is the LazyList state, because we're going to use LazyColumn, for example. So let's create here a private variable. Another case is we want to have the onMove. So the onMove here is going to help us to move items from one item to another item. So whenever we're going to be moving components. Okay, so this is going to be a state holder for managing drag and drop operation within a LazyList, for example, a LazyColumn. So it's going to handle detecting drag, starting, tracking drag movement, and identifying the order targets so that we can reorder items by using the offset. So inside here, we're going to need several parameters that we can use to actually keep track of this. So for example, the drag index. So let's create here a variable. Okay, so the index, this one is going to be a mutable state and basically a mutable state of an int. Okay, so we can make this first private set so that we cannot set the items inside here. Another case, we want to actually store the LazyList item info. So the item that was initially picked up for dragging. So this one we can keep in here the stage. So let's create here a private. Okay, so here we are going to keep the LazyList item info. So the information for this. Okay, so another case here is we want to get the onDrag started. So this one is going to be called when a drag gesture actually begins. So we can identify the item that was touched so that we can get the offset and also do different initial things. So let's create here the onDrag start. And basically the onDrag start here, the parameter which we're going to need. Not the index, this is actually the offset. So we can get the list state and layout info, and we want to get the visible item information. So here basically we want to find the first item whose vertical bounds contains the drag start offset. So for this case, we can get first. We can find the first one now. So here we can use a simple calculation. So we can get here the offset y. Okay, so we want to identify here the offset. So we can get our first offset here and we can look at all items so that we can identify the first item. So if the item is actually being found, so here we can just call it let. So first we can change here the drag index. So we can set the index of the item being dragged and actually store the initial item. So here we can store initial. So we can assign it as our initial item. So this one is going to be the first start. So whenever we start to drag, basically we want to set up this. So first we want to find that item. So we can use this item and look through all offset that we are going to have inside the layout info. Now after that, then we can actually set these items so that we can start to use them. Okay, so the next case is we want to call a function continuously when we're dragging an item so that we can update our items. So we can create here a function and call this onDrag. Okay, so we can just call this delta. Okay, so this one is going to be called continuously when we are dragging. So basically we can change here and actually we can create another. So let's create here a parameter where we can understand how far has our item been dragged. So we can create here a drag distance. Okay, so we can use this and call it private set. Okay, so the distance, and by default, we're going to start at 0. Okay, so when we are dragging here, we want to actually change here the distance, because the first item we can call the drag distance equals to delta plus y, because we are moving it vertically, so we can use delta dot y as the offset here. Okay, so the next case is we want to get from the index where we are starting to actually drag this, and here let's create a variable. Let's call this from index. Here we can call drag index. If this is going to be null, then we want to clear return. So we don't want to proceed with anything because the initial index is not actually set up. So you cannot move any item. And also the from item, which we are going to start to move the item. So similarly, we can just call here the list state. Okay, so we can create here a simple extension item to actually find that item. Okay, so below here we can create a private function. So we can find the item info, and here we can pass in the index that is going to be of type int. And basically this one is going to return a lazy list item info. And this one can be nullable. Okay, so here what we want to look is actually this is an extension function to actually efficiently find the item for a given index among the current visible items. So here we have visible items and we want to find that particular information, and using an index. So here basically we can call return for the layout info, and we want to find the visible info items. So we can find first on null, and we can use int.index. This one is going to be equal to index. So this one is going to be actually an item. Okay, so let's go back here inside the on drag. Okay, so inside here we have to find now the item info. And here we can pass in the from index where we are starting. And if this one is going to be nullable, also we have to return empty because we should not proceed with this. Okay, so we can get our initial offset where the item is actually going to be there. So we can just call here initial item offset, and if not, then we can just return here. Okay, so now we want to get the boundaries of that particular item that is going to be dragged. So we can just call this current top. Okay, so here we can call our initial offset and actually plus the dragged distance. Another case is we can get the current bottom, so we can get the current top and actually plus from item.size, so that we can get actually the current visual top and bottom boundaries of the dragged item. Okay, so we want to find a target item to actually make reordering among the visible items which we're going to have. So for this case, let's call here our list state, and here we can get our visible items info. Now we want to filter here. So the first item which we want to filter here is actually the item that is being dragged, so that we can get the rest of the items and actually calculate the dragging between items. So for this case, we can just filter the index here, so we can get this. If this is not going to be actually from the index, so okay, so another case is we want to actually find the overlapping items. So we can actually find out the drag item itself and find candidates that actually are going to visually overlap. So we can create a simple extension function to actually understand which item is going to overlap. I think that one is going to be more readable other than just typing them here one by one. Okay, so let's go below here. Let's create another extension function. LazyList item info, and actually let's look for the overlaps. So the first case, we can get the top, which is going to be an int, and actually the bottom item, and then this one also is going to be an int. This one is going to return actually a boolean. Check the offset. If this one is not going to be less than this, and actually if the offset plus the size is going to be greater than. Okay, so for this one, an item is going to overlap if its top is actually below the length is bottom and its bottom is actually above the top. So for this case, we can know, okay, this item is going to overlap. Okay, So we can just go back here. Okay, so it's if actually also it's going to overlaps. So we can just call here overlaps. So we can call here current. So current top. We can convert these two events and actually current bottom. So basically here we can filter out these items. So we are going to filter out the dragged item itself and actually find the candidate that actually visually overlaps that item. Okay, so after we filter out this data, then we can find the first or okay, so here we can find our candidate that is going to be our item. Okay, so we want to check here actually from the overlapping candidates, if we want to find the one that the drag item has crossed over so that we can actually move it, and we can be dragging in two ways. So for example, we can be dragging top or we can be dragging on bottom. So for this case, if we are dragging, so we can write here, if the drag distance, okay, so if the drag distance is actually less than 0, then we are going to be dragging downward. So for this case here, we can try to change our item. So we can call here our current bottom. Okay, so we can call here our candidate size. So here basically we are dragging upward, and else if we are not dragging upward, so we can just call our current top is actually less than candidate top set. So we want to get that item, and here basically we are going to get from the overlapping candidate, find the one that is going to be the dragged item is crossed over. So here we can check if we are dragging downwards, then we can check if that item's bottom has actually passed the candidate bottom. So here we have found the target item. Now we want to call the on move, and here we can move from index. And here we can call our target item dot index. So here the item is going to be shifted, and here we can call our dragged index and actually initialize this to the target item dot index, and the initial item is actually going to be the target item right now because we have changed this. Okay, and here now we have released, so we can change the drag distance back to 0f because we have already reached the particular items where we want. So we can reset the drag distance here, and everything is going to be set up correctly. The next case here is whenever we finish up to drag everything, we can try to, okay, so this one is going to be the drag, and let's create another function is on drag end. So here we have finished to drag the item, so we can reset everything back. So we can set the drag index back to now. Drag distance here, we can set it back to 0. Your item, we can set this back to normal. And if we have anything else here, we can try to actually stop this. Okay, so another case, we want to get the drag offset so that we can perform with animation. So we can calculate the visual offset that should be applied to the composable, actually representing the draggable item. So this offset makes the item visually follow the fingers, even if after underlying data is going to actually reorder. So for this case, we can get here, let's create this function here. Okay, and this one is going to return float. So for this case, we can call here our region, the virtual item, and here we can get our offset. And if not, then we can just return 0. Okay, so our original item. So the offset of that item no need is going to be picked. Then you can get here the actual offset of the item based on its current drag index inside the lazy list. So let's call this current. So we can find the item info and call here the drag index. And if the drag index is going to be 0, then we can just return 0f. Okay. Now, after that, we can get the offset. And if the offset is actually null, then we can just return 0. So, okay, so if it's none of them, so we have to just return directly here 0f. Okay, so now after we get this, we can just return here. So the visual offset is actually the initial position plus accumulated distance and here we can minus the item current position. So this one is going to ensure a smooth visual movement regardless of data reordering actually. Okay, so for this case, we can just copy our original plus draggable distance minus the current. Okay, and here we can just call return 0f, and this error is going to go away here. Okay, so now the current is actually going to be empty. So here we can find the item, and if it's nullable, then you can return 0f, and if you actually the offset is not 4, then you can just return 0f. So I think here everything is actually working perfectly for now. Okay, so here we have our state, and this class is going to help us to actually keep track of that draggable. So we can create here a composable function, and this function here we can call remember. So here we can just remove this. Call here remember LazyList state. So in this case we can put our LazyList state, and here we are going to have a lambda function on move that is going to return unit. Okay, so here we have created a remember drag drop list state. So you can pass in here the lazy list state and on move. And basically we can use here remember function so that we can use to remember this data. Now, after that, we can create here an item that we can use to actually put our items here. Okay, so below here, let's create a data class, and let's just call this item. So you can use any type of data class for this. Okay, so one thing is that we want an ID that is going to be of type int, and name that is going to be of type string. Okay, so this is are going to be our items. Okay, so there we have our list state. So let's directly come here, say down in activity. Okay, so let's create here a new composable. So we can create here drag list screen. Okay, so here we can create items. So let's call this items, and here we can create a remember function. And here we can pass in a mutable state list of several items. Okay, so here we have, for example, apple, banana, cherry, date, elderly, 6, and also you can just keep any type of data. So inside here we have our data. This is going to be our remember. Okay, so here we're going to create our item. So after that, we can create a lazy list. So let's call this list state. Create a list state. Okay, another case is we can create our drag drop state. Lazy, we can call here remember drag drop list state. Okay, so here we can pass in our lazy list state, and pass in our lazy list state, and move. So we can have here from into. So now let's call here our items, and so here we can just call to add an item. So we can pass it to. Okay, so for this case, we can add remove an item from a certain place. Okay, so here we have our drag drop list state. So we can create here a LazyColumn. Okay, so we can change here the state, call our list state. Let's give it a modify, fill in max size, pass in here the pointer input, and for key we can just pass in here units. So here what we want to do is to detect drag gesture after long press. So this way we can easily, so we can put here a drag drop state and call on drag start, passing here it. Okay, so when we are starting on drag end, we can call again on drag drop state, call on drag end, similarly, and drag cancel, call drag end because we cancel it. So another case is the on drag. So here it's going to be called continuously whenever we have a drag item. So the first item we don't want. spot here the drag amount. So let's call here our drag drop state and call our drag and pass in here the drag amount, which is just the delta that we have set. Where is our lazy column? So the first case we can just call here items index. Okay, so we can pass in here our item. We can use the key. Okay, so here we're going to use the item and we can use item.id as our index, actually the key. So in order to increase the performance of our lazy column here. Okay, so we have here our index and actually their item. So we can check if actually we are dragging. So we can call the var is, so we can get the index. It's going to be equal to index. You can know, okay, this item is actually being dragged. Okay, so the next case is I want to create a simple box so that we can display our items. Here we can fill the max width. Now let's pass in here the graphic layer. So we can use this one here in order to actually add animations when we are moving items. So let's change here our translation Y. And here we can check if it's dragging. So we can use here our drag drop state. So we can get that offset as we can just give it a 0f. Okay, so we can create that translation. If not, then you can just give it 0f, create the shadow elevation, and check if it is dragging. Can give it something like 8f, else we just give it 0f for that particular animation. In other case, we can change the background, for example. Let's go with background, and we can check if it is dragging. We can use a material theme. So we can use the primary color when we are actually dragging on that item, and also we can use, so we can use it there. And here we can change the shape, for example. Let's use rounded corner shape and give it something like 8 dp. So lastly here we can give it a padding. Let's just give it 16 dp so that we can add a little bit of breathing room. Okay, so inside our box here we can create the text to actually show that particular item. So let's just give it and give it an item. Okay, let's add here its cursor so that we can just differentiate these items. Let's give it 8 of 8 dp. Okay, so here we can use modifier. Let's use state. Okay, so inside here, let's create a column. Let's call the max size and give it the padding. Let's use the inner padding of this particular item here. Okay, so for our column here, let's create here the text. Let's call this drag and drop this. Let's change the font size to 20 sp, for example. So I think that is just enough. So inside here, let's call here and drag drop list directly inside here. Think of the thing is going to look okay. So now let's try to rerun the application and actually see the changes we have made. Okay, so here is our items actually launched. So now let's try to click. So we have all the this, and when we try, you can see that it's actually changing, leaving it here. Let's try to take this 8 and send it to the top. You can see it's moving and actually changing here. So let's keep it at the top. So we have to press here and actually it's moving. So guys, if you find this video helpful, please don't forget to provide a like, subscribe and share for more videos. So until next time, see you in the next video. Bye bye for now.